Thanks everyone for joining us. This is a presentation that I'm really excited about. We have a guest with us today, um, and we'll be talking with Jacqueline Nolis, who is from SaturnCloud. Jacqueline, if you just want to say hi to everybody, we'll introduce you here in a second.
Hello.
But so she is with a company called SaturnCloud. We'll learn more about that here in a minute. I'm with Business Science, and this is a presentation entitled The Future of Time Series, where we will be focusing on high performance forecasting systems. This is also a learning lab. It's learning lab number 53. I cannot believe I've done that many so far, and it's exciting. I feel like we keep every week we keep kind of upping and upping the level. So with that said, we're going to be learning a lot about time series today. We're going to be focusing on one package called Modeltime GluonTS, which is for deep learning. But we'll also be focusing on GPUs, which is why we have NVIDIA down here. They're sponsoring this event today. Also, SaturnCloud, we'll be talking with Jacqueline a little bit more about their product and data science platform. Okay, so let's get started here today. We do have a short agenda. I'll touch on that in just one second. But first, Jacqueline, please introduce yourself to everyone.
Yes. Hi. So I'm Jacqueline Nolis. I am the head of data science at SaturnCloud. And so SaturnCloud, which we'll talk about, it's a tool to help data scientists like you do cool computations in the cloud easily. And so we are very interested in what are all sorts of the applications of when you have easy to use GPUs and DAS clusters and things like that. And so when we saw some of this material being presented, we're like, oh, this is really cool. Let's see how we can use our tool to help.
And just a little bit of background. So one of my students, Florian, actually put Modeltime GluonTS, which is what we're going to be doing today. He actually put the first version of this demo together, and he used SaturnCloud, their service, to do so. And that was actually how eventually, just kind of behind the scenes, how I got linked up with SaturnCloud. Then they reached out to me. Their CEO, Sebastian, reached out through LinkedIn saying, hey, what are you guys doing? I see Florian's putting stuff on LinkedIn about, our platform. This is awesome. And then that's, how I got linked up then with Jacqueline, who's their head of data science. So it's pretty cool. It ends up being a small world. And I'm excited because my students are actually using your products, Jacqueline. So that's great.
Well, and 3 years ago, I actually saw you presented our studio comp, and now we're presenting. So there's a lot of small world stuff happening here. Yeah.
Yeah. That was back before COVID, when we were still attending conferences in person. Now it's all virtual.
Right. Yes. Back in the day.
All right. So you guys know me. My name's Matt. I'm the founder and CEO of Business Science, where we have an educational platform where we teach data science for business. I'll talk more about that program and specifically the time series course at the end. The agenda for today, we're going to be actually doing the code first. So we're flipping the script. We're going to be doing some code first. We're going to go through a demo where we showcase the SaturnCloud platform, how we can easily access GPUs, and how we can run then a deep learning analysis where we forecast 7 time series at once. So that's pretty cool. Then we'll jump into the meat of the presentation, which is actually going to give you a lot more details behind the Modeltime ecosystem and be centered around this idea of a high performance forecasting system, really explaining what that means, what I'm seeing out there in some of the competitions that are going on and how that relates and how we can learn from some of these things. And then at the end, Jacqueline's going to wrap things up and she's going to do a demo on SaturnCloud. So you can actually take all of the code that I give everyone here today, you can take it and run it on SaturnCloud for yourself. So this is kind of new. Normally, I don't give out the code unless you join Learning Labs Pro, but today is different. You're going to get the code. And then at the end, we'll wrap things up with a short Q&A. Okay. So if that sounds good to everybody, then let's get this thing kick-started. As promised, we're going to be doing a demo first. So I'm going to hop over. I've got in my browser the SaturnCloud platform running. And what I'm in is called a project. So if I click out here, there's many different projects. The one that I'm running right now is this Model Time Test 3 that I have written. And then what I did was you basically connect up an environment to a workspace. Your workspace has so I'm right now what I'm doing is connecting up to this Amazon Saturn R Modeltime GPU, where I've got a Jupyter Lab running. So when I click on that, it opens up my Jupyter Lab, and I'm ready to get started right where I left off. So this is where the tutorial kicks off. And Jacqueline, is there anything that you want to say about kind of behind the scenes, what's going on right now and what we're doing?
Yeah, so basically what's happened is you just, your code is connected to a project, which is a combination of a GPU and a cluster and all these things. You can adjust these settings after you make them and stuff. That's very customizable. And I will also just say, because I don't think we explicitly mentioned it, there is a free version of this. So, if people watching this want to try this out after, you don't actually have to put in your credit card. You can just try the GPU stuff, which I think is just really cool because I don't like paying for stuff.
That's how I started. So I used their first, I think you give 10 hours free or something like that. And I was just playing around with it, and I got this demo working in that amount of time. So
yeah, 10 hours of free a month.
Oh, that's per month too. Okay, I thought that was total. Yeah, oh, yeah. Okay, cool.
We changed it. Yeah, yeah.
Nice.
Anyway, you can present the stuff. I just like talking about it.
Well, no, that's new. That's news to me. I'm glad you mentioned that. I'm pretty pumped about that actually. All right, so this is the code demo. Basically, what we're going to be doing is we're connecting up to GPUs. We're going to be running my Modeltime GluonTS software, which actually runs Python under the hood, but we're going to be doing it through an R kernel. So if you see over here, it's R. And I can select a kernel. I actually am running R in Jupyter Notebooks. So what I'm going to do is I'm just going to kind of run down through the code, and I'll explain how what's going on behind the scenes. So this first thing is probably, if you're an R user, you're probably not used to seeing this, but what I'm doing is I'm pointing to a specific version of Python, an executable, that allows me to connect up this Modeltime GluonTS package to the Python environment that's being run underneath the scene. So we're going to be running, again, we're running R here, but we're actually connecting up to Python under the hood. And I'm going to load in a few libraries here. We've got Modeltime, we've got Tidy Models, we've got Modeltime GluonTS, the main package, and then we've got Tidyverse, TimeTK, and so on. You may not have seen this before either. I do have a little kind of option that I'm setting here to help with ggplot, the way it prints in the Jupyter notebooks, to make them a little bit wider, 16, because my screen size is very wide. So that'll help out. So you guys can hopefully actually see the plots when I plot ggplot. And I will be plotting also plotly plots as well. So some interactive ones. Okay, so what I just did, I hit Shift and Enter, and it ran the libraries that I need for this tutorial. Also, what I'm doing here, I'm going to check and make sure I'm running this line, and I want to know if GluonTS is activated. So basically, I'm testing that this connection string, my Modeltime GluonTS was able to connect up to it. And I get a true down here, which is what you want to see. If you get a false, you just refresh the session and change the GluonTS path to the appropriate path to your Python. Okay, cool. So Jacqueline, just real quick too, behind the scenes, this is a special version of MXNet that we're running. So I want to make sure everyone understands that we are not just running any version of MXNet, but we're running the one that connects up to our NVIDIA GPUs. That is the beauty of what we're able to do here, right?
Yeah, and you don't have to there's a little stuff we've done on the back end to make the GPU stuff easy, so you don't have to. In general, it's just you just select, I want to use the GPU stuff, and then this works. It's not like you're messing around with CUDA drivers or anything like that.
Right. So the key advantage here too, like these deep learning analyses, they take a little bit of time to run. You're able to offload that. So if you have 10,000 time series, you can actually you leverage the platform to offload that from that work from your local machine. So you're not tying up your CPU on your MacBook, you know. So the next thing I'm doing, I'm pulling in my data. We're going to be using this data set called Walmart Sales Weekly. It's just the first 6 rows that you're seeing here. It's a pretty, it's got 7 different time series to it. And we'll actually see that as we go through the visualization. But here's kind of what the data set looks like. We're mainly going to be focusing on the ID, which stands for the store ID. It's a combination of store and department. And then the date feature and the weekly sales. So the date is the timestamp, and we know what the weekly sales are. So the sales are aggregated at a weekly duration for each of these store ID combinations. Okay, and that's what's going to make up one time series. And we have several other IDs, 7 of them total, which are different stores and departments. Okay. The next thing we're going to do, so we've got a time series that we pulled in here. We're going to first come up with a forecast horizon. So this is where you talk with the business and they say, you know, hey, we need to know for the next, you know, half a year or so what our sales demand is going to be at a weekly duration. Can you do that for us? And you say, oh yeah, no problem. And, you know, in the back of your mind, you know, you've got some tools in your pocket being Modeltime and TimeTK, and you've got a new software library, Modeltime GluonTS that you want to try out. So what you do, you get this information from the business. They say 28 weeks. So that's how you're going to set up your analysis. You're first going to, before you just jump into forecasting, you're going to do a training and test set. And this is kind of something that's common in machine learning, maybe not as common in forecasting, but this is how we get our confidence level. So we're going to split up our Walmart daily, our Walmart sales weekly data set. We're just going to grab the ID, date, and weekly sales columns. So ID, date, weekly sales. And we're going to do an assessment set where it splits up the forecast horizon, the last 28 days for each series, and it's going to run that automatically for us. So you're going to see a little warning message here, and or actually just a message here, and that's just telling you that there's that the data is not ordered. So it's going to order it for you, and then the overlapping timestamps are detected, which is, you know, makes sense because we've got several different time series in here. So it's going to split it up into 805 by 196. So that 196 doesn't exactly match 28, but if you do 28 times 7, that should total up to 196. And then what we can do is also visualize the time series. So I'm running this next line of code here, and what I'm trying to do, and this is a ggplot, I'm going to make this interactive true, which is a little bit better for exploration. I was doing ggplots just behind the scenes. I do ggplots when I want to save like a notebook because it makes the file size much smaller if I don't have plotly files in here. So this is the interactive version, and what I'm doing is I'm checking to make sure that I've got a duration here that makes sense. It looks like it starts at 2012, 04, 20, and then it moves in the next 26 weeks or so. So there should be like 26 of these little bounces here. Okay, so now that I'm pretty happy with that, here's the fun part. This is the line, the code that runs our first deep learning model. So what I'm doing here is I'm timing it, and I'm just setting up some parameters. So this is Modeltime GluonTS. It has this DeepAR function. And what I'm doing is I'm setting an engine to GluonTS DeepAR, and I'm just going to fit that using the formula weekly sales as a function of date and ID on my training set. So that's what's running right here. It's going to take a few seconds to run, but what it's going to be doing, it's fitting that DeepAR model for us in Python, like underneath the hood. It's connecting to the Python GluonTS library, and it's also using the NVIDIA GPU GPUs as opposed to CPUs. So it takes about 20 seconds or so, which is pretty fast. And I've also found you get a much better, like as you start to increase your epochs, it takes a lot longer. And it also, as you increase your data set size, it takes a lot longer. But the difference between doing it on like my MacBook versus doing it on the GPUs, it starts to be heavily favored towards the GPU is what I've been seeing. So now I've got my model developed here, and I can see it took me about 19.2 seconds to make it. And then next, what I'm going to do is I'm going to kick myself over into the Modeltime workflow. I'm first going to calibrate, which is where I then collect the residuals from my model when I forecast them on the testing or the out of sample data set. And then I'm right down here, what I'm doing is I'm taking those residuals and then I'm going to pipe those into model time accuracy just to see what the accuracy level is. And this is designed to help me get a confidence, some confidence estimates. If you're trying to tune, you would then tune your models to these, trying to reduce, one of these error metrics or increase R squared. Higher is better. So we're trying to increase that particular metric. Once you're pretty happy with your model, we want to visualize it. So we're going to use this function called model time forecast. Because we have multiple time series in here, we're going to group by ID. So this is basically like a wrapper for predict that kind of groups everything together for you. And then we're going to use plot model time forecast for the visualization component. I'm going to set this to true, and I'll just run it really quickly. So true takes a little bit longer, and that's just because there's a plot that's being generated. It always seems like Plotly takes a little bit longer to output than like a ggplot. And you can see this is, if I zoom in on this, and if I just get my little pan grabber here, I can kind of move these around, and I can see that the forecasts, I can check to make sure that they look like they're doing a decent job. And for the most part, it seems like they're doing okay. We could probably tune it and get some better results. Next, what we're going to do. So now that we're pretty comfortable with our parameters, we're ready to move on to the next step, where we're going to do a refitting process and we're going to forecast forward. So I'm just going to briefly go down through what I'm doing here. I first need to create a future data set that's going to be forecast. The key component in this section of code is this future frame. What I do is I group on the ID, and then I produce a forward-looking future. So if you see here, our last date is what? The 2012 10/26, and you can see we've got 2012 11/02. So this is the next timestamp that we would want to forecast forward. That's what this future frame is doing. So we're just basically kind of shifting everything forward so we can get a future data set to predict on. Next, what we're doing here, I'm going to run this while I talk. I'm using another function called model time refit. And generally what we want to do is we want to train on the whole data set now. So that's what we're doing. But we're starting with the calibration tibble. So those residuals from that test data set, which gives us our confidence. And you can see here, this one went much faster, 10.5 seconds now. So that GPU got faster. So it must be nice and warmed up now. And what we're doing though is we're training on the full data set, because that's going to give us the best predictions into the future. And then the last component here, what I'll do is do interactive true and run this. We're just actually running basically the same code that we did here, except we're switching off the new data. Instead of doing a testing data set, what I'm doing is I'm popping in the future tibble, this future data tibble right there. And what that does is it predicts forward what the next 28 weeks of data should look like. And you can see here it's making those predictions for us, and they're looking pretty good visually. So that's all there is to it. That's the demo for today. This is all code. I'm going to give everyone access to it right now. I have a link over here.
Can I idly muse on this for a minute before you go into this?
Sure.
Yeah, this is just mind-boggling to me, because like my first job out of school was forecasting, and this was like 12 or 13 years ago. And like back in the day, it was SAS, and you had two options. You could do exponential weighting, or you could do a REMA, and that was it. And like, oh, hey, now we're using GPUs and deep learning, and it's like 10 lines of code, and now you're doing it for like, I don't know. It's just like, and the plots are interactive now. Yeah.
I see a 13 here. Isn't that crazy? Okay. Like,
yeah, I don't know. I feel nostalgic a little.
Yeah, we'll talk about what it took to what I've condensed into these 13 lines here in a little bit. But it really makes for a good story. And I can't wait to discuss that with you guys next. So for everyone, I just put all the code in the chat. So you are now getting access to this GitHub repo, which contains all of the code. It's got a nice little README here. It also has some instructions for how to fire things up, which Jacqueline kindly put in here and made sure that they're all correct for you. And then, obviously some thanks for the sponsors. We'll talk a little bit more about the ecosystem here in a second, but you guys now have access to all the code. The IPython notebook that we showed is right here. So if you just go into the code folder in the IPython notebook, it's right here for you. And as I said before,
I will say sorry, but
I'm sorry, what was that?
There's a little lag. Sorry about that. I realized I did make some minor changes like 5 minutes before the presentation and my pushes weren't getting merged. So just wait. If you're going to do the SaturnCloud stuff, wait like 10 minutes after this presentation. I think I just didn't have the right permissions to push it. So.
No, that's a good point. And we'll make sure that the updated version, so just kind of hang tight on the SaturnCloud portion. But we do want you checking. We do want you checking that out for sure. All right, so that was the demo. Now I want to talk about more of the background about high performance forecasting, where this term comes from, what I'm seeing out there in the field, and why, and some of the new challenges that we're facing. So business forecasting, whether you see this or not, it is changing. So we're seeing that businesses are collecting a lot more data than they were in the past. So that means there's a lot more data out there, meaning as at the product level now, you might see a forecast being made versus, in the past, maybe it was done at a weekly or a monthly level or a quarterly level. So now you're seeing tons more data. That data tends to be higher frequencies. The scale is increasing, and we need a lot more automation because we're doing so much more now in terms of forecasting. Before it might have been like, 12 or you might be forecasting 12 different time series. Now what we're seeing is you're forecasting 12,000 time series, and that's where the scale really increases, and we need automation. So I'll give you a story. I've consulted with many companies. I also have students that are consulting on the time series end. And what we're seeing and what I've seen with certain clients is that, they come to me and they're normally a business person. It's a, executive. They get a project kicked off, and one of the issues that they might be having is they're seeing, big spikes and shifts in demand because of, some events are happening, and they want to get a better handle on it. So they come to me and they say, hey, I need a data scientist that knows time series, can improve forecasting, and I need it done for 10,000 time series every day. And, I listen to that and I'm saying, wait, what? 10,000, what? And, this is now, it's the new normal because we have these organizations that are changing and they're saying, hey, I need, I just saw this product that just spiked and it totally threw off our manufacturing processes. We need to get a better handle on this for next month. Otherwise, it's going to cost us millions of dollars. You start looking into it and you're like, hey, you've got 10,000 SKUs, which are products, in your database. If you want me forecasting all of these, that's a lot of work. I don't even know if I could run it on my computer fast enough to keep up with how often you need these forecasts. So let's take a step back. So that 10,000 number, what they're really asking for is they want a high performance forecasting system. So if we decompose the statement, what he really meant to say is, I need you to make a high performance forecasting system. And we'll talk about what some of the key ingredients are there, but it's basically doing this for either products or customers. This might be one customer that you're seeing, and you need to do this for their whole database of customers. And you can see you're making several models for this time series, and then you want to aggregate it, and you want to make sure it's as accurate as possible. So basically, this times 10,000. How do you accomplish that? And that's what I want to talk about today. So we talked about this change that's happening, and just to kind of recap. So forecasting, back 5 years ago when I started, really getting into more statistical methods of forecasting, I was mainly doing, monthly time series. I might have had, 10 time series or so that I had to forecast every month, and I was using simple ARIMA. So now, if you fast forward just 5 years, five short years, forecasting in 2020, and now it's 2021, daily time series is probably more common, honestly, than monthly time series. I'm being requested to forecast at a daily interval. We want to get as close as possible. We see that the scale, because of this higher frequency, that scale increases. So you don't just have 10, products, you have 10,000 products. So you have to do 10,000 time series. And because of this, we have new technologies that we need to implement to be able to solve these newer problems. The standard ARIMA is no longer, you can't just run a loop. It'll take you a month to get through 10,000 time series. And when your organization needs that, faster, they need it every day or every week, then that's not going to work. So let's talk about this high performance forecasting system. So an HPFS, what companies want? If you break it down, there's three different properties. So the first one is that it's got to be accurate. It's going to improve results, meaning this is going to be something that when a company implements it and you help them do that, it's going to improve their organizational results. So something like 10% improvement might be your benchmark for the project, and that benchmark should save that company millions of dollars if you can do it at a much more granular level rather than forecasting, at monthly and not doing a very good job forecasting, per SKU or per product or customer. So this is why that organization wants to invest in you as the data scientist, bring you on board so you can build this for them. So property number one, it delivers the best possible results given your resource constraints. So what that means is if a company needs it daily, you should be, if you can't do it daily, then you're not meeting their objectives. Most companies probably don't need a forecast daily, but it's probably going to be more frequently than at least maybe once a month or once a week. They're normally looking at and adjusting their manufacturing processes and whatnot. The second component, so it shouldn't just be accurate, but it should also be kind of understandable in terms of when something's kind of going awry. So what happens in companies, and this is what I've seen a lot, is where they build a model and they say they use ARIMA. They put that into production, meaning they run it, they've tested it once, and then they've put it, into feeding their manufacturing system the results every month, for in perpetuity. Well, what ends up happening is, that ARIMA that they fell in love with so much at the beginning of the project, a year down the road, it doesn't work that well anymore. Their time series has changed. Maybe something has happened, and these models are no longer, that good. So the second property is your forecasting system should be able to report some sort of results, and you should be able to know when something is going wrong. So this is an example here of like what Modeltime allows us to do. We can do a lot of experiments, experimenting with many different models, and then each month they shift, depending on what you want, what you're trying to go for. Like if you want to say reduce your RMSE, this is the best model here, profit with XGBoost for this particular data set, at this point in time. But in a month down the road, it could be this GLM net with lags incorporated. That might be your best model. So you need to be able to adjust and kind of make sure that you're able to do the job of the forecast, which is high performance, and accuracy is a big part of that. The third property of a high performance system is scalability. So if a company needs, at a SKU level or a product or a customer level, That means that there's scale involved. So multiple time series. And what ends up happening is you have to do something like this for like 10,000 of these different things, or it might be 500, whatever the number is, that's up to your business, but you have to be able to scale your analyses up. And that's the third challenge. So, or the third property. So you want to be able to scale from one to many time series, and you need to be able to do that at the frequency that your business needs it, whether it's daily, monthly, weekly, whatever they need. So that's what you're trying to do. You have to automate. That requires some level of automation. And this is what we're going to be talking about today. So when I first got involved with high performance forecasting systems, it was a little over a year ago. I really started doing a lot of research. And what I found was that the best things to research wasn't by reading the books that had been written or studying the papers that the universities were putting out. Don't get me wrong, I did some of that, but I found that the thing that matched this problem the closest was forecasting competitions. And this is because those competitions have the same properties that we're looking for in a high performance forecasting system. So if you think about it, these competitions that I'm talking about Kaggle, and I'm talking about some of these other competitions that are out there where they're trying to forecast, thousands and thousands of time series. They want to maximize the results, and they're having to report accuracy. So these are the same identical properties that we need in a high performance forecasting system. And I'm going to talk about 4 different competitions. I have them listed here. We're going to talk through each one of these and kind of show you the solutions to those problems and what I saw when I was doing the research. Okay. So we're going to get started with, and I'm going to take it back to 2014. First off, there's the Walmart sales forecasting challenge. And I'm starting actually with the second place solution. So I didn't just review one solution, the top. I reviewed probably the first 5 or so, depending on how much I could get information on. The second place solution was actually the most interesting for this competition, because this solution that this gentleman put together was in the first spot up until the very end. And then the guy who won it actually did some kind of manual modifications, tweaking some certain variables, which that ended up winning it for him. But this is the most probably scalable and reproducible solution. And it was the best up until almost the end. So he got second place, but he was first place, up until the end. So what strategies, and this is what was so interesting to me, was that he was kind of back 2014, when I would have thought, okay, he's going to use the traditional stuff, ARIMA, exponential smoothing. No, he was using machine learning. So he did use ARIMA, but he also had random forests, and he had k-nearest neighbors, and he had some more machine learning and univariate models. And you can see he's got some different results. But what he did, and these are the 6 different ones that he for the individual models that he had made. And then what he did was he did a simple average of the above 6 models, and that improved his score down to 2,421, which for this competition, lower is better. So this was kind of the key here, is that 6 bad models make 1 good model. The power of ensembling different strategies. So he ended up getting second place, but he had a solution that is easy to automate. And it's something that we can generally do. We can create individual models, we can experiment, and then what we can do is we can combine those models. So that was the first one. So ensembling was really important, and we see this kind of dynamic of machine learning with kind of your more traditional forecasting methods. The next one is the website traffic forecasting competition. What I was so interested in was the first place solution, because this is the first competition where I saw deep learning, which we just did, but deep learning being a major factor in creating scalable forecasts. So this website traffic forecasting competition, this is not an easy competition. So they have website data, it's at a daily frequency, and you can kind of see these spikes in here. And what we're seeing is that there is so many websites that Wikipedia has, because this was a Wikipedia challenge. What he found was Arthur, who had won it, was able to win it using a recurrent neural network that he was also using some regressors as well. He had probably the most complicated code that I've ever seen in a forecasting challenge. Using bare bones TensorFlow, he built this mega LSTM that just kind of, has probably like 8 modules to it, and it's pretty crazy, all written in Python. Very impressive, but clearly to solve a problem, it was a lot of code and probably put a heck of a lot of time into it. So good thing he won it, because that was quite the time investment. But at the end of the day, the most important piece here is that an LSTM was very powerful. He found it to be very similar to ARIMA models, but much more flexible and expressive. So this is a key idea. And the thing that I saw was he could use this at scale, which was something that ARIMA is very challenging to do. The third competition here. So this is from the M4 competition, and the first place solution, again, implemented deep learning. Now, this is a hybrid model where they combined both exponential smoothing with deep learning. So a more traditional model with a kind of a deep learning model. And they won by 3%. So they beat, and in a forecasting competition, that's a lot. That's actually quite a margin of victory. So you can see it over here, estimate 9.4, 6.6, 5.7. So this is normally what we're used to seeing, 6.6 and 5.7. They're pretty close. But you can see that first place is so much better than the other two. So that's what we're looking at. And also in more recent news, the NBeats algorithm was run on the same set, and it even improved on this top solution. It got even better. So, and then most recently, the last competition I'm going to talk about today, the M5 competition, which is the most recent one. It was daily data from Walmart, and this is the winning solution here. They've used both. What was interesting here is that they use the power of feature engineering. So prices, calendar features, lag features, rolling lags. They used machine learning, so like GBM, kind of like XGBoost, a tree-based method. And then they use ensembling. So again, kind of this approach of combining different models into a final model. So here you can see it kind of shown graphically. They did a lot of pre-processing with engineered features. They did both recursive and non-recursive methods for, at the lowest level, the store ID and category ID, and the store ID and department ID. And then they also did non-recursive methods. So they created 6 sub-models, and then they produced a final prediction. And that's what they call here stacking or ensembling. They're basically just coming up, kind of blending those models. So these competitions we can learn a ton from. And this is where it becomes really powerful, because the takeaways are things that we can then take to our jobs and be able to implement this high performance forecasting system. So I've got 5 takeaways here for you. The first one is feature engineering. This was very important. We saw this in 2 competitions, the M5 competition. We saw it for the daily time series, where calendar features were really important, lags, rolling lags. Being able to engineer these features became super important. The second one, experimentation and ensembling. So we have to create lots of different models. We can't just fall in love with ARIMA. We need to try and do multiple different modeling approaches. Don't go in with any sort of preconceived notion like, hey, this model is going to work best. Experiment. Let the data tell you, and let the results tell you which ones are the best, and then take the best of breed and ensemble them. And we saw this winning many of the two of the competitions. A third one, I really didn't talk a whole lot about this, but knowledge of key events was important. So having key data in there, like specific holidays, that helped out the Walmart challenge and improved accuracy about 12% for the first place submission. Machine learning and deep learning. These are two newer technologies that we haven't seen traditionally implemented in forecasting solutions, but these are the ones that are winning the competitions. So either like GBM or the deep learning, especially with these when you have lots of data. Okay, so what I was going to do, and I'm going to focus on, again, the competitions, because what I did was I ended up putting a course together. And what I wanted to do when I first set out was I was just going to try and showcase the best in class methods that I was learning from these competitions. And what ended up happening was, as I started to do that, I ended up trying to replicate some of these solutions, and it was taking me so much lines of code. So the problem is that, you know, these Kagglers that are spending months and months on these forecasting problems, it's just not productive, because you're writing so many lines of code to make, you know, 6, 10, 15, 20 models in order to be able to test different strategies out. And this is kind of how I felt when I was coming up with the first iteration of the course. I was typing 2,000 lines of code to making multi-model forecasts, and I was like, man, there's got to be a better way. So turns out that this gave me enough fuel to actually build something. And what I do when I face these problems is I'm trying to think, you know, how can I improve the situation? One of the ways is I came up with this idea for software called Modeltime. So what it does is it integrates the classical models. It also integrates machine learning, profit, but most importantly, it takes what we've learned from the machine learning competitions at Kaggle related to time series, the M4 competitions, the M5 competitions, and it provides a way for us to implement these best-in-class machine learning and deep learning algorithms in a scalable way. Meaning we're going to create one model and we're going to be able to predict for many, many time series. So what this does is it increases our productivity, it decreases the amount of code that I have to write, and it improves the speed of experimentation. So this is the Modeltime software, and this is kind of the base package. So it's got a special workflow to it where we kind of follow this process where we create these models individually. And then once we create the models, we fit them. Then we use this structure called a model time table. And what that does is it organizes everything for us. Then what we do is we follow a best-in-class approach that comes from the machine learning side of things, not the forecasting side, but rather machine learning. We split it into a train and test set. We calibrate on our training set to our test set, and we get the residuals from out of sample from our test set, and we visualize or we produce accuracy results. Then those accuracy results are saved, and it continues on as we go on to our next stage, which is refitting the model and then forecasting forward. So that's where we get these out of sample accuracies, and we can do it. And I'm just showing one time series here, but you saw here on the Jupyter Lab, we just did 7 time series down here, and it wasn't much different. There's going to be some group buys here that we have to remember to include, but for the most part, it's kind of going to follow this process. Next, what Modeltime does is it implements and integrates experimentation into the workflow. So you can see here, what I've done is I've just created here 1, 2, probably 30 different, 28. I see this is the largest number that I'm seeing here, 28 different models. And I put it into a model time table. This is what the output looks like. And then I'm able to sort it here by RMSE, and I can see which ones go to the top. Bingo. I now have a way to experiment very quickly, and I now have a way to filter down to the best models. And I have now a process that I can keep work through in an automatic way every week or every month to be able to update. So that's what Modeltime gives us, the ability to experiment, the ability to basically rapidly come through and do all the things that we need to do. Here's a visual. We're taking some of the top models here for this particular series, and then we're able to then do things with them. So hyperparameter tuning, time series cross-validation, that all comes inside of model time. All right, cool. So I just consolidated, here's the real result. I just consolidated my 2,000 lines of code into 300 lines of code, or even less. Big time win. But model time doesn't cover some of the best-in-class forecasting solutions. So what about feature engineering? I haven't talked about that one yet. We saw that in the M5 competition, that feature engineering part of it was really important up here. So model time takes care of this stuff down here and the modeling strategies. We'll talk about stacking here in a minute, but the pre-processing is something that's really, really important. And this is also, when I was analyzing the Kaggle competitions, this is where most of the code is. This is like 4,000 lines of code when I'm trying to repeat, some of these solutions and replicate them. And, the you're trying to visualize, you're trying to inspect, you're trying to, figure out what outliers are there. And you're trying to do this for 28 different models. It ends up being like 4,000 lines of code. It's really annoying. So I made TimeTK. And what it claims, feature engineering, it covers data wrangling, visualization, and pre-processing. But really what it does is the same thing that model time did for the modeling process, TimeTK does for the feature engineering and visualization process. It increases your productivity, it decreases your code, and it improves the speed of feature exploration, which is really critical if you're trying to do these high performance forecasting systems. So here's an example. Feature engineering is now being simplified here. This is literally one line of code, taking my data, and I have a formula that I came up with that I wanted to test, and I wanted to see how it looks, to see if it's getting some of the variation in my data with these particular features. And I just literally just do this one line of code here with the formula that I've created. And then it outputs the visualization for me, and it gives me the information on all the different features that I wanted to test. So it really speeds up everything. And this is something that would take lots of time and effort. It's now just much, much simpler. What about deep learning? So we've already kind of talked about deep learning a little bit, but I made some extension packages, and I made this one called Modeltime GluonTS. The beauty of it is if you learn model time and that workflow, this is just a different back end that we connect up to. And once you learn the basics of the feature engineering and the time series analysis and the machine learning workflow and the tuning, you can apply it to any back end. So you can then now quickly switch over, plug and play model time Gluon, bring in a deep learning model, throw it right into your workflow, just like you've got an ARIMA model or a profit model in there. So it just works the same. And that standardization speeds you up, makes you much more productive. What about scalability? Well, this is where we're going to talk with Jacqueline here. She's actually going to do a tutorial for us at the end. But the SaturnCloud software and being able to leverage this kind of data science at scale is a key idea to a high performance forecasting system. And what's nice is using a platform like SaturnCloud, what you can do is you can basically offload the work and you can automate the work on somebody else's computer, not your own. And that's a key component because you need to be doing other stuff. You don't need to be, babysitting a time series analysis while it runs for several hours. No, you need to be doing other work, researching, and let the automation happen somewhere else. So that's where SaturnCloud comes in. And we'll talk a little bit more about SaturnCloud here. Let me do real quick. Let me jump into this first before we do the demo, Jacqueline. So what I want to say is, if you're interested in learning the first part of this program, so the model time, the time series analysis, the machine learning, the ensembling, the GluonTS, this is a system that I've developed. It'll take you a long time to learn on your own, but I have good news. I've created a new course. I released it several months ago, and it's gotten rave reviews. There's some exceptional things going on, and I'll have more information on that soon. But we've steadily been building this ecosystem we've got a ton of stuff that's already baked in, and also more stuff coming. That's really going to be mind blowing. I'm excited about it, but it's got a lot to it. So you got your machine learning, your ensembles, your back testing, GluonTS, and so on. So how do I learn this? So let's just recap. We've got feature engineering. That's really important. We've got model experimentation, the ability to build many different models and automate that process. And then I didn't talk about the ensembling portion, but there's actually a package that I put together that integrates ensembling. That's a key component, and that's something else I want to talk about here in a second. And then learning packages like GluonTS. Well, this is actually a course that you can that's available for purchase. It's something that will transform you into the data science time series expert, forecasting expert for your organization. I'm going to put the link in the chat, and then I'm just going to briefly talk about it, and then we'll jump into Jacqueline's demo. Here is the link for the time series course. There you guys have it. The time series course, it covers about 9 hours on feature engineering, everything that you're going to need to do, several challenges as well. So you got visualization, data wrangling, transformations, machine learning. As you can see, the bulk of the course, 18 hours or so, is dedicated to all of the things that you're going to need to do. So not just machine learning, not just deep learning, but ARIMA, profit, exponential smoothing, TBATs, the traditional algorithms, machine learning algorithms like XGBoost, like GBM, those sorts of algorithms, boosted algorithms. So these are algorithms where we take one of these models, we utilize them for their strengths, and then we boost their residuals. So it's got those in there, and those are some that I've actually built myself. It also talks about hyperparameter tuning, which is essential for both the sequential models and non-sequential. Sequential models are things like ARIMA, where the order matters. And then you've got non-sequential models like XGBoost, where the order doesn't necessarily matter, but the features matter. And then ensembling, which is with this Modeltime ensemble package, being able to combine your results and blend them to give you the best possible predictions. And then scalability with time series group. I have 3 hours on that. And then deep learning, we've got 6 hours using Reticulate, R, and Python, and GluonTS, and several different algorithms in that package. And also the Modeltime GluonTS software is what I built for the course. So check that out. If you're interested, you will not be disappointed. It's an insane course. It'll get you promoted. It'll take your career to a whole new level, and you'll be that time series forecasting expert for your company. All right. So that is my part of the presentation. Now I want to kick it over to Jacqueline. I'm going to allow you to share your screen here. So I'm going to stop sharing mine. And I'm going to say all panelists. There you go. You should be able to have access now.
Great. Okay, so I just want to real quick show people a little bit about SaturnCloud if you want to try running GPUs, including for free, 10 hours each month. So just a little bit about what is SaturnCloud. Here's my slide. It is a slide. Yeah. So it's really the point of SaturnCloud. It's a tool for data scientists. And it's really, for people, and I saw this questions in the comments, if you're like a data scientist, you're working on a laptop, your laptop has a set amount of memory, and you're like, I wish I could just run on a computer with more memory. We will help you do that easily. Or I want to be on a GPU. We can help with that. If you're in Python, we also help with, I realize I'm away from the mic. If you're in Python, we also help if you want to run a distributed cluster of code with Dask. And we also can do jobs and deployments. So if you want to have a continuously running dashboard, if you want to retrain a model every day, we have stuff set up for that too. And what Matt was showing earlier, so this is what SaturnCloud looks like when you log in. And there's really two kind of important areas. One is you can create projects. So a project could have materials in it that we kind of suggest, like examples and common setups, or you could create a custom one. And then you can have the projects you've already made. And so I have a project called GPU time series, and this is exactly the same. It's like a copy of what Matt was running. And yeah, I can just hop into Jupyter Lab and I could do the same code Matt was running. I also, if I wanted, I can go into the settings and I could change it to, instead of, I could actually set it, instead of having 1 GPU, I could have 8 GPUs and 500 gigs of RAM just by, maybe don't, that's expensive, but you could. You could also, if you're, so not in R, but if you're using Python, you could, hey, if you want to run, if you want to in Python train 100 separate, time series at once, you could attach a Dask cluster and just have the stuff be done distributed. So it's all pretty cool. I will say we are primarily a Python tool. We do, like, as you can see, we do have some R, but it's not as well supported. So there is limited stuff. So like in the instructions to get started, that's included with the repo. You'll see there's a couple of extra steps you have to do because it's R, and that's just how it is right now. And we understand that. But I think it'll be really helpful. And yeah, you get like 10 hours of free GPU each month to try out. And if you need more than that, you can, the prices are reasonable. And yeah, we're really just trying to be a tool to like help you get out of the, oh no, I ran out of memory. Oh no, I need a GPU. Oh no, I need 10 computers running at once. I will also say, lastly, you can do things in Jupyter, but you can also, if you don't like Jupyter, you can run from Visual Studio Code and you can SSH into our worker server. And also, if you're in Python and you want to use distributed computing, you don't even have to use our worker server. You can have your code running on your laptop, and just when you want to do stuff on a distributed computer system, you just pass it to Dask that way. So there's a lot of ways to use this tool. You can do deployments and jobs to have things run once a day or continuously, like a dashboard. And yeah, I mean, I'm a very excited about stuff person, and I really get excited about this tool because, again, like 10 years ago when I was doing the time series and SAS on old Windows machines, like something like this is like really would have just been a game changer. And it's really cool to be at a company where we can help provide that to other people. So
yeah, and yeah. Just to add to what Jacqueline's saying, the bottom line for me, you need to be productive as a data scientist. And the key for me that SaturnCloud really helped me with was being able to transition from like, okay, I'm running my analysis on my computer like every day or week, to like, oh, I've got now more resources available to me. I don't need to run it on my computer. I can free up that time once I create, something that needs to be, say, run all the time or once every so often. You can schedule that out. You can do the automation. It's also got like the Dask cluster. I haven't experimented with that yet. It also has the deployment option. I haven't experimented with that yet, but just being able to run something on an automated frequency can really save you some time. And, you just go in, you download the results, once a month or once every week, and it's right there for you. That's powerful, and it doesn't need to be any more complicated than that. And like Jacqueline said, like there's separation between the Jupyter server that you're running and the environment. You just pick out literally, which environment you want. If you want the V100 with how many gigs of RAM? That was like 500.
Like 500, and you can have 20 Dask machines each with a V100. So that's 8 times 20.
Yes. So be careful. Like, be careful with the
100. Yeah, it's
once you see the bill for that might be a little expensive.
Not the free version. Yeah.
Yes, but if you need it, you can have it, and that's really cool. Unlimited power, but wield that power responsibly.
Yeah. And as you said, actually, that first job I had where I was doing time series, I also had to manually press the button once a week to rerun the forecasts, and just having something automated would have been really cool.
Yeah. Because you go on vacation, like it sucks having to interrupt your vacation. Oh, hey, at this point in time, it's Friday. I got to do my forecast. Let me click this button. I'll be back with you guys in 20 minutes. So just a real quick recap here. This pretty much concludes our presentation. I'm going to share my screen really quickly. And so we talked about everything that we needed. We've got the demo up and running. I put some links in the chat, and you guys should have access to all the links for the presentation. I'm going to put them in one more time. Let me just do the chat real quick. Yeah, just bear with me a second, guys, and we'll do some Q&A as well. So let me do the chat. Okay, here are the links again. So for everything that we discussed today, Learning Labs, if you want to join that, Learning Labs, this presentation is being recorded. It's going into LL Pro. SaturnCloud, if you want to check out their platform, I've got a link there. The GitHub repo for all the code, I'm giving that out to everyone this week for free. Check that out. And then the time series course. If you're interested in becoming that forecasting expert for your organization, check out the time series course. It's really good. All right, so we got a little bit of time for some Q&A, and I'm just going into the Q&A section here. And I'll just kind of read off. So the first one was, would you share the notebook? Check out the links. We just shared them. The next one, are the hyperparameters in the DeepAR function tunable with Tidy Models Tune dials packages? Yes, they are. We have some of the dials functions incorporated, like epochs and so on. Check out the documentation. You can tune them. And that's another reason GPUs are really good. So one of my students is really into deep learning. He has requested, a lot of the dials parameters, and he uses a different data science platform to do his tuning. But he's doing it on GPUs in the cloud too. All right. My question is why we use GPU acceleration support. This is from Gokhan. Is it for big data, something else? Thank you. Jacqueline, you want to field that since you're kind of the
Yeah. So there are certain types of models like neural networks you can use on the GPU, but once they get to a sufficient size, it's just there's millions of parameters and GPUs take forever. And it just so happens that GPUs are they're for graphics, right? They're for video games, but it just so turns out that the same like linear algebra for video games is the same thing you want for training a neural network and other types of models. So it just, you hit a certain point where for your model to finish in any amount of time, you have to use a GPU. So I don't know with any particular time series data set if it makes sense to use GPUs there, but getting used to neural networks and being ready to use GPUs when you need to is like it's so important.
Yeah, the epochs, the number of epochs ends up being really important. And also there's probably like 10 hyperparameters. So you do need to do some tuning there in order to be able to be sure that you're getting the best model. And that just takes, unfortunately.
I'd say batch size especially. Like yes. A sufficiently large batch size you need a GPU for.
Okay, cool. I'll field the next one. So this one comes from Konstantin. They're asking, what are calendar features? And so that's a really good question. And I talk a lot about this in my time series course. We calendar features. There's lag features. There's rolling lag features. There's splines. There's all sorts of features you can create. But we'll talk specifically about the calendar features. So that's basically when you take a timestamp, think of it like a date, like the January 1st, 2012. You can break that out into a bunch of different features from that. Like, for example, what day of the year is it? Is it a Monday, a Wednesday, a Friday? Is it the first day of the year or the 365th day of the year? What month does that timestamp fall into? So each of those are what we call calendar features. They're basically features that are dependent on that timestamp. And there's inside of the TimeTK package, there's a recipe called step time series signature. It's really important. And what that does is it turns that timestamp into like 35 different features that can be used for machine learning. Some of them are more useful than others depending on what your timestamp is, but it automates that process.
Could I add a 3-line story?
Yes.
My first job, I was doing forecasting. One of the things I forecasted was the volume to the call center coming in. And I built a new model and I forgot to put the calendar feature of Thanksgiving. Is it Thanksgiving? Yes or no? I forgot to include that. And Black Friday. I forgot to include Black Friday. And it turns out suddenly one day my model was deeply wrong. And I got a phone call from a very high level person at the company. So be careful with your calendar features.
Yes. Yeah. The, things like holidays too. There's a step holiday signature as well. Very useful for preventing those types of issues. When you've got sales demand that is very dependent on specific holidays throughout the year, like Black Friday, Cyber Monday, that sort of thing. I can tell you from business science, our experience, that Black Friday, Cyber Monday, and also the Christmas holiday. Those are our best times of the year. People just like to buy courses and like to take courses in December. I will tell you that. Okay, let's see. Does model time do cross-validation? So Carl has this question instead of a single train test, like what Profit does. So this is a great question. And there is another package that I have not talked about, and that is called the, can you guys still see my screen? Mm-hmm. Okay. So this is called Model Time Resample. And what Model Time Resample does, and I'm going to put this link in there for you, is do the time series cross-validation. So a lot of times what ends up happening is that we want to know what the stability is of our models, and we want to be able to understand, how that model changes over time. And a single train test split just isn't enough to give you some sort of statistical evaluation. So there is some resampling techniques where you can split it out, and then you can calculate what the error is on each of those different segments or those sections of the time series. And you can do it, for a bunch of different error metrics. So that's what this does. We've got our different slices. So we've got 4 different slices here. And what we're doing is we're calculating how the model error changes. And we've got 3 different models that we're looking at: ARIMA, Profit, and then GLMNet. And then you get your accuracy table. So yes, we can do that. All right. Let's see, what else do we have? Do you fit 10,000 models separately or as one whole model? So this is from Guthaman, and I apologize if I don't pronounce your name correctly. 10,000 models. So no, we do not do that. That's not scalable. That's what ARIMA does when you run it in a loop, and it takes you 6 months to get a forecast. What we do rather is we have to have a lot of RAM, and when we have 10,000 forecasts, so we have to have, typically it might be, you're limited by the RAM on your machine. So that's your resource limitation. But if you have to do a 10,000 time series forecast, what you need to do is you can build one model that forecasts all of those 10,000 time series. And that's much more scalable. It may take 3 hours to train it, if you're doing hyperparameter tuning or whatever, but you have access to the resources like SaturnCloud. You have access to model time where you build a single XGBoost model, or maybe you're doing several different models, XGBoost, a DeepAR, and so on. And you have to use models that can scale by building one model for many time series. So only certain models do that, and I teach that in my time series course. Okay, GoCon. I have a data which just includes date and measurement values, almost one measurement data in each month, nothing else. My aim is to make a forecast for future values for another 3 months. Should I use the model time package? What do you suggest? What I would do, definitely the model time package is the best in class system. It's going to make things super simple. And it's going to give you kind of a best in class framework that is going to take you through all the steps you need to do to make a good forecast. But you need to know how to use it. And I think that, I would recommend the time series course to get training. That's me personally. If I was in your position, didn't know much about time series, wanted to make some forecasts, have data, need to know how to do it, that's what I would do. Beyond that, the model time package, it'll definitely work, but you need to know how to use it. And that's what the course teaches. Okay. What would you do if your data, and this comes from Carl, what would you do if your data had a different pattern from weekday to weekends? Do you model it together or separate the weekend and weekday? Well, this happens quite frequently in time series, where you can imagine, if you work in a certain companies, when you are working, say Monday through Friday, you have sales. And when you're off on, Saturday and Sunday, then you don't collect sales. Some businesses operate that way, like traditional retailers, if they have a certain day of the week that they're off. And then you're going to have those, big drops in revenue on, like Saturday, if they're off on Saturday. So There's many ways that you can model it. I can't, number one, there's not one thing that always works in time series. You have to experiment. So you have to try out different things. Maybe take those Saturdays out if they're always off and model them separately. Maybe try and do all of it together and just have a feature, a day of the week, calendar feature. You know, it just depends. Maybe even your solution is just to, instead of forecast the time series, maybe your solution is to try and forecast maybe a rolling average, because that's really all your organization cares about. You know, it depends on the time series. You need to experiment. It depends on the business question, which is, you know, what does your business truly need? Okay, let's see, GoCon, I want different models to take, test, and choose the best in research. Well, that's kind of what I already showed already. The experiment, just experiment with model time. Carl, let's see, we've been answering a lot from Carl. I'm going to skip Carl for now. Ravendra, do you have a discount code for academics? Ravendra, we don't have specifically for academics, but I would suggest reaching out and let me know. You know, feel free to email me and let me know what the situation is. Paul Dong, in terms of the time series forecasts, is the model presented using a recursive method or not? Well, DeepAR is an autoregressive model, but it's not using the new recursive function that I'm going to be talking about soon, which is coming to Modeltime. That's a new feature in 050. I haven't had a chance to announce it yet, but that's coming. Seth, implemented Modeltime in a competition environment. I don't know of anyone. I do know that my students are getting really good results with it for their organizations. Also, one of my students, actually, it's not Modeltime that he implemented. He implemented Anomalize. They've got a big thing going on right now that I can't even talk about, but it's going to get national press. That's, you know, all of the software that I write is very good, and it's going to help you become more productive. I don't really necessarily care about competitions, although it would be great to see, you know, Modeltime in competitions. What I really care about is making sure that you're productive and you're able to get good results for your organization. And I can tell you that it's doing that. Can I share the slides as well? I'm going to be doing all of this in Learning Labs Pro. So check out Learning Labs Pro if you're interested in getting like the video and everything. Leaderboard had around 1000% MAPE. MAPE's a bad number to go off of. I always go off of RMSE or MAE or R squared. 1000% MAPE, that could just be because it's forecasting a product that only has maybe like a unit 1 sales, or if it goes to 0, then your MAPE skyrockets. So it suffers from issues with small values. How do you handle holidays in different countries? The step holiday series, it's the step holiday function in TimeTK. It has a bunch of different holidays from a bunch of different countries. Venkat, okay, here's a SaturnCloud question. Will SaturnCloud have the capability to handle all the TimeTK and Modeltime functionality as it looks to have limited support for R as compared to Python? I will say this.
Oh, sorry.
Oh, I was just going to say, I had no problem using it for, you know,
good.
For the GluonTS. Now, I will say this, you know, if you want to try and use Dask is Python. So would I be fair to say probably not with that?
And I would just say that the, you know, we are Python first. And so a lot of our tools do work with R, but we don't, if things are having trouble, we don't have like a set list of things we can do to solve it with R. Like it's more, it's not as well supported yet by us. So you can do R stuff as we've shown here, but there might be a little bit of like, you have to putz around with it to get it to work. You know, it's not like fully supported in the way that we support Python, but you can still use it.
Yeah. Well, what I'll add to that though is like, I really don't have any issues, because what it allows you to do here is you can run startup scripts. So you can literally install any software you want on their machine, and you just build it like you would build a Docker container, or, that's kind of what I equate it to, and you can let me know if I'm wrong. But honestly, like, you can customize, everything. When she says, when Jacqueline says supported, maybe that's kind of like something that I'd like to explore a little more. But like, the fact is like, as long as you know how to make kind of your own environments, you're really unlimited with what you can do.
That's right. And we do have lots of Python pre-made environments, less so with R. So if you're willing to make some of your own, it should be pretty reasonable. And we have like the one we made for this demo. We have some R existing ones already that you can then try and add packages to beyond that and stuff. So I guess I'm just really trying to hedge so that the engineers on, like in my team, we are not like committing ourselves to levels of service we may not have. But I do think, I've been pleasantly surprised at how well R's worked. As a person who's used R for 10 years and have only recently gotten into Python.
Yeah, I would say this. So Florian, I've seen some of the conversations with him and the SaturnCloud people. They seem really receptive to helping him out, and he's an R guy. So, and he's the one who actually made the initial example of Modeltime GluonTS. So I would say, like, if you need Dask, you're probably gonna have to do Python. But if you are okay with running R just in the cloud, and you don't need to have like multiple clusters, but you just want access to like a something with some power behind it, I would try it. It seemed to work well in my case. I mean, this didn't really take much time to get up and running. Okay. All right. Well, we're going pretty long on time here. Let me do one more set. Okay. So John Peter Sabini, he says he sees Snowflake and associated IPA on Saturn. Are there any other additional associated platform as a service like DigitalOcean or AWS? Or does Saturn have a dashboard on usage?
Yeah, so a couple of things. So for usage, right now, you can see on the left, you can see how much of your free time you used right under that billing. You can see, so Matt's a like friend of Saturn, whenever he has slightly more than the standard free version, but he's used 24 out of 100 of his monthly hours. So you can kind of keep track of usage there. We do have a more in-depth usage page, but I think it's one of these things that we know we're going to continue to flesh out too. We do have connections with SaturnCloud. We have relationships with NVIDIA. We are actively pursuing a couple more partnerships that I'm very excited about. So there's more coming. I will also just say, I saw a comment of someone said, well, why would I use SaturnCloud if I could just spool up a Docker container in AWS? And it's like, well, if you are comfortable spooling up a Docker container in AWS, you are welcome to do it. But oftentimes I find when creating Docker containers, especially with GPUs, it's like getting the drivers to work right is a hassle. And getting it, especially if you want to use Dask or something like that, where it then connects a whole cluster of computers, we just kind of want to make that easy for you. But if you're like, I know how to start a Docker container in an EC2 instance or whatever, and I'm chill with that, that's it. There are good solutions for everyone, and we're pretty proud of this one. So
yeah, this was I was pleasantly surprised at how easy it was. So if you want ease and you want quick, definitely give SaturnCloud a look. All right, so with that said, I'm going to wrap it up here. We covered a lot of ground today. I'm pretty excited about it. We talked a lot about SaturnCloud. If you want a copy of this video, we're going to be putting it into Learning Labs Pro. So let me put the links in there one more time. And if you need to get the access to the code, I'm putting it in there again. And if you want access to the time series course as well, you're welcome to check that course out. It's really good. So, and thank you so much, Jacqueline, for being on the Learning Labs today. I really appreciate it. You were awesome. So thank you so much.
Oh, thank you. Okay, take care, everyone.
All right. I'll see you guys until 2 weeks for the next one. We're going to be doing the new Tidy Models workflow sets package, which is really cool. So I'm excited for it. All right. We'll see you guys. Bye-bye.